All right, the last section of chapter 3, 3.7, we are factoring by division. Now there's two types of division we're going to look at today, long division and synthetic division. Now before we jump into polynomial long division, let's refresh our memories with some regular long division stuff we learned back in elementary school. Let's say I wanted to divide 54 by 3. So 54 divided by 3. First of all, how do we even set that up? There's different ways we can write it, but using long division, we would say, okay, we want 54. And we're going to divide that by 3. So we want basically the big thing that's being divided on the inside here, and then the other number on the outside. Okay, and then how would we do long division? Well, first I want to see how many times does this number go into that number. So 3 goes into 5 one time, so I write a 1 up there. And then what do we do next? Well, I do 3 times 1 gives me 3. I write that down here. And then what do we do with that 3? We want to subtract it. Okay, and then 5 minus 3, I get 2. And then I bring down my next number to make it 24. And now I want to say, okay, how many times does 3 go into 24? And 3 goes into 24 18 times. I'm sorry, 8 times, which makes it 18 up there. And then 3 times 8, I get 24. And then what do we want to do with that 24? We want to subtract it. And then what does that give me? 0. Okay, so then I have a remainder of 0. What does that mean? Well, it means 3 goes into 54. In other words, 3 is a factor of 54 because I can write 54 as 3 times 18 or 18 times 3, doesn't matter the order. Okay, so if we do long division and we get 0 as a remainder, it means that this thing was in fact a factor of our original number. Okay, so we want to keep that stuff in mind when we do polynomial long division because even though it looks a lot more complicated, it's pretty much the same repeated steps. Okay, now here are the steps to polynomial long division. We're not going to read over these. You can read over them if you like to, but you don't really need to. You'll see why in a minute. Just bear with me for a sec. Let's dive right into the first problem. All right, so example number 1, we wanted to divide using long division. I want to divide this thing by x plus 2. And then we want to know, is x plus 2 a factor of that thing? And we'll address that in a minute. But first, how do we do this polynomial long division? Well, I want this thing divided by that thing, so how do we set it up? Okay, well, I need my little bar thing here. And then I want x squared minus 3x minus 10 in here, and we're dividing it by x plus 2. So then that goes on the outside. Hopefully we have enough space here. All right, and then we're always just focusing on the x. Don't worry about the 2. That'll come into play later, but we're going to focus on the x. So how many times does x go into x squared? In other words, x times what gives me x squared? Well, x times x gives me x squared. Okay? So then that's my first part up here. Next, just like with the numbers, once I have the number up top, I multiply this number times that thing and figure out what I'm going to subtract. Okay, same thing here. X times x plus 2. And in fact, those of you taking notes, go ahead and put your pens and pencils down and just pay attention here. You can copy these down at the end and just pause the video. But just pay attention to what I'm doing here real quick. X times x plus 2, I get x squared plus 2x. Okay, and then what do we want to do with x squared plus 2x? I want to subtract it. Now be careful because I want to subtract both parts. So we need parentheses there. So that would make it negative x squared and negative 2x. And then when I subtract x squared minus x squared, that's gone. That's 0, so that's good. And then negative 3x minus 2x would be negative 5x. Okay, and then bring down our next number just like we did up top. And then start over. Okay, now I'm focusing on x and this number here. What do I have to multiply x by to get negative 5x? Well, I got to multiply it by negative 5. Okay, and then negative 5 times x plus 2 gives me negative 5x minus 10. And then I want to subtract that from the thing above it. And then just barely enough room here. If I got negative 5x minus 10 minus negative 5x minus 10, I'm left with 0. Okay, so then we had a remainder of 0. So what does that mean? Well, that answers this question over here. Was x plus 2 a factor of this thing? Yeah, because when I did division, I had a remainder of 0. So then, yes, it is. And then these were the steps to doing that. Okay, if you want to pause the video and write these steps down real quick, you can. And then we'll move on to the next problem. Okay, now you'll notice that the next problem says divide using synthetic division. And hopefully you notice also, it's the same problem. So we're going to show you a different way to do the same problem. Okay, so when we use synthetic division, it's pretty much the same process. We're going to end up with the same answer, but it's a different way of doing it using only the coefficients, the numbers in front, and not all of the, not all the x's and stuff. Okay, so when we're doing synthetic division, what we want to do, we want to set it up like this. We're going to have a little box here, and then a bunch of numbers next to the box, and then we're going to have a little line down here, because we're going to be doing some arithmetic. Okay, what number goes in the box? Okay, well, whatever we're dividing by, so whatever binomial we're dividing by, we want the zero, the root, the answer to that binomial in the box here. So since we're dividing by x plus 2, I want to put -2 in the box. Okay, and then what numbers go up here next to the box? Well, then I want the coefficients in front of my polynomial. In this case, it's my trinomial. So I got 1x squared minus 3x minus 10. So I just want the numbers, no x's. Okay, and then once we have it set up like this, now it's just a little process here. We start by bringing down our first number here, and then whatever number's below the line, I want to multiply with whatever's in the box. So 1 times -2 is -2. And then I add these two numbers and put it below the line. -3 minus 2 is -5. And then next, -5 times -2 is +10. Okay, and then -10 minus 10 is 0, and this last number is always our remainder. Remainder of 0 means that, yeah, it was a factor, which we know it's a factor because we just did it this way. Okay. Also, just like we set up at the top, once we divide and get a remainder of 0, that means that 3 times 18 is 54. Well, same thing on our last problem. Since this had a remainder of 0, that means that x plus 2 times x minus 5 equals x squared minus 3x minus 10. And then, yeah, that is correct. Okay. All right, so here we divided using synthetic division, got a remainder of 0, and then what are these two numbers? Well, just like these three numbers were the coefficients, these are now also coefficients. We're going to reduce our biggest power by 1, so instead of starting with x squared, now this is going to be 1x to the first, and then minus 5. So then this is the binomial that I'm left with. Okay, so we had our original binomial of x plus 2, and then we're left with x minus 5 because x plus 2 times x minus 5 gives me that thing. Okay, and then, yeah, this is a factor. Okay, now you can probably tell just from looking at the work, this way of doing it is a lot easier than the long division. Okay, so the reason we kind of glanced over these rules, because of time this year with the COVID and everything else, we're kind of cutting some things out. We're not requiring you to do any polynomial long division. Okay, but I did want to show you how it works and show you that synthetic division gets you the same answer with just a lot less work. Okay, so we're never going to have to do any problems like this. This was just to show you that it worked using something we're kind of familiar with, just not with polynomials, but with numbers, and then show you, hey, this is the better way to do it. Okay, so we're going to do all of our problems this way from now on, just using those coefficients and synthetic division. Okay, so the next problem, divide using synthetic division. So we want to divide this thing by x minus 2. Okay, let's see. If x minus 2 is my factor, then what goes in the box? Well, if that's my factor, my 0 would be +2, so I want to put that in the box. Now, it's easy to mess that up, but if you mess it up, if they're telling you, I'm sorry, that's not correct for this problem. Sometimes they'll tell you that, yes, this is a factor, and if they're telling you it's a factor and you don't get a remainder of 0, well, then you made a mistake somewhere. Here, we're actually checking to see if it is a factor, so we got to make sure we put the right number in there. But yes, x minus 2 is our factor, 2 goes in the box. Okay, and then my coefficients are 2, -5, +3, and +7. So then I put those coefficients up there, draw a line down below, and then I start the process. Bring down your first number. Down here, I get the 2, and then multiply down here, whatever number's down here, times whatever's in the box. So 2 times 2, I get 4, and then put that in the next spot there. And then next, add these two. So -5 plus 4 is -1. And then I want to multiply -1 times 2. I get -2. 3 minus 2, I get +1. 1 times 2, I get 2. And then 7 plus 2, I get 9. So I had a remainder of 9. Okay, so is x minus 2 a factor of this thing if I got a remainder of 9? Well, no, because I got a remainder other than 0. So then no, this one's not a factor. Okay, so there's another example of synthetic division. Let's go right on to the next page. We've got a few more examples. All right, so one more, just practicing using the synthetic division. So first thing we want to do is set it up. So let's see, I got to have my box, and then what goes in the box? Well, x minus 2 is my factor, so then a positive 2 goes in the box. Okay, next, my coefficients in front of the polynomial are, now let's see here. Be careful when you get a problem like this, because we have x to the fourth, and then it jumps to x squared. I don't want to skip any powers of x. So another way to write this polynomial would be I got 1x to the fourth, and we can even put the 1 if we want to. And then plus or minus, doesn't matter. How many x cubes do I have? Well, none of them. So we can put 0 x cubed minus 2x squared plus 5x minus 3. Okay, so then my coefficients are, I got a 1 in front of the x to the fourth. I got a 0 in front of my x cubes. I got a negative 2 in front of my x squareds, plus 5, and minus 3. So anytime you skip a power of x, you need to put a placeholder in there, a 0. It'll make things work out correctly. All right, next draw our line. So we bring down the first number, we get a 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 2 plus 4 is positive 2. 2 times 2 is 4 again. 5 plus 4 is 9. 9 times 2 is 18. And then negative 3 plus 18 is positive 15. So we got a remainder of 15. So then was this one a factor? Was x minus 2 a factor of this thing? No, it was not. Okay. All right, next, how are we going to actually apply this stuff? Well, sometimes we're going to have to use synthetic division to help us factor something before we can graph it. Okay, so for example, if we want to graph the following polynomial, 2x to the third plus 3x squared minus 39x minus 20, and we know that one of the factors is x minus 4, well, then we can use this to help us factor this thing so that we can get our x-intercepts and graph this thing. Okay, because you might think, well, there's 4 terms. Can we factor by grouping? Well, we can try, but it won't work. Okay, because once we take out a GCF here and take out a GCF here, the 2 binomials, they won't match. So factoring by grouping is not going to work. Okay, so here, again, we want us to factor using synthetic division. I got a minus 4 here. We're going to put a plus 4 in the box. And then, let's see, we did not skip any powers of x, so that's good. My coefficients are 2, 3, negative 39, and negative 20. Okay, now, I've been going kind of slow to make sure everyone's keeping up. But this is how quick this can be once you get it down. Once you get it set up, bring down the 2. 2 times 4 is 8. That gives you 11, 44, 5, 20, 0. Okay, now I'm not trying to erase or anything, but it's just multiplication and subtraction. So you can go through that pretty quick. All right, and then what are we left with? 2, 11, and 5. So those are the new coefficients in front of our x values. Remember, we want to reduce the power of x by 1. So instead of starting at x cubed, I'm going to start here with x squared. So now I get 2x squared plus 11x plus 5. Okay. Now, something that's easy to forget is that, yeah, we've started to break this thing down from this down to this, but it's this thing times x minus 4. That's one of the factors that they gave us. So don't forget that in your answer. Okay. And then we're not done yet. We want to continue to factor this so that we can get our x-intercepts. So x minus 4 is still a factor. And then how can we factor 2x squared plus 11x plus 5? Well, I know my signs are the same and they're both positive, so plus and plus. I got to have something times x and something times x to get 2x squared. And then let's see, what multiplies to 5 and adds up to 11? Well, nothing, but that 2 comes into play. So let's see, how are we going to make this work out? We need 2x plus 1 and x plus 5. Okay, that would give me 10x, that would give me 1x, which adds up to 11x. Okay, so now I've got this thing completely factored. Now I can get my x-intercepts. So I've got one x-intercept at negative 5. You get that by setting this factor equal to 0. If we set that one equal to 0, we're going to get negative 1/2. And if we set that equal to 0, we're going to get positive 4. So set all your factors equal to 0 to get your x-intercepts. They're all raised to the first power, so I know it's going to go through each of those points. And then next, I can either use my end behavior, which I can get from my original equation, or another point, which another point's easy because there is our y-intercept. I know my y-intercept, if I stick in x is 0, that goes away, and that goes away, and that goes away, and I get y is negative 20. So I'm going to have a point down here somewhere at 0, negative 20. Okay, and then from here, I know it's got to come up, hit this point, go through, come back down, hit that point, go through, and go through there. So then let's see, low to high, does that fit? Well, it's odd and positive, so then yeah, low to high looks good. So our graph would look something about like that. Okay. So sometimes we have to use division to help us factor. When do you have to use division to help you factor? Well, the giveaway is whenever they give you a factor. If they didn't give us this factor, we'd probably try using factoring by grouping since there's 4 terms. Okay. All right, now, sometimes they're going to give you a factor, sometimes they're going to give you the root or the 0 or the answer. So up here, they gave us the actual factor of x minus 4. Down here, they're giving us an answer, a root of negative 1. So given 1, 0, factor and sketch the polynomial, label the x and y intercepts. Okay? All right, let's do the factoring part first. So we're going to do synthetic division. We're going to have a negative 1 in the box. I'm going to have 1, 4, negative 15, and negative 18 as my coefficients. And just double check to make sure we don't skip any powers of x. So 1, 4, negative 15, negative 18. And then just start multiplying and subtracting. So bring down the 1, multiply, negative 1, 3, negative 3, negative 18, positive 18, 0. And again, they're telling us that this is a root, so we should definitely get a remainder of 0. Just like up here, they told us that this was a factor, so we should definitely get a remainder of 0. Okay? Now these remaining coefficients now are the coefficients in front of our x's, and we got to reduce our power of x by 1. So we're starting instead of at x cubed at 1x squared plus 3x minus 18. Okay, so I got this thing, and since negative 1 was a root, I got a factor of x plus 1. Okay, and then we want to finish factoring this trinomial here. So don't forget the x plus 1 is going to stay in our answer. And then we can factor this thing into 2 binomials. To multiply 2 numbers and get negative 18, I got to multiply a positive number and a negative number. And then I got to have x and x to get x squared. And then what multiplies to 18 and has a difference of 3, 6 and 3 will work. The bigger one has to be positive, so positive 6, negative 3. And then don't forget, you can always check your factoring by multiplying it out. If I multiply these 2 binomials, I should get this trinomial. Okay? It works, that's good. When are each of these going to equal 0? That's going to give us our intercepts. So when x is negative 1, that'll give us 1 intercept here. When x is negative 6, and when x is positive 3. Those are our 3 x-intercepts. And then again, we can use our end behavior or another point to finish our graph. Since we need the y-intercept anyways, they asked for it, then we'll find the y-intercept. If I stick in x is 0, I get y is negative 18, so that was easy. 0, negative 18. And then since these all have a multiplicity of 1, they're all to the first power, I know it's going to go through at each of these points. So it's going to come up here, go through. It's going to come up here, go through, come back down, and go through. So then low to high. So let's see, does that support my equation? It's odd and positive. So yeah, low to high looks good. Okay. So this is how we factor using division. And again, you never have to do the long division. The synthetic division is easier and faster. You can always do it that way. And then that wraps up the notes for chapter 3.